We are students from GMU University pursuing BTech CSC 5th semester. I am Annapurna SK, and today we'll be presenting on cloud deployment models and virtualization for Cognizant under the subject Serverless Computing and Cloud Functions. Here comes the introduction. Cloud computing delivers computing resources like servers, storage, and databases over the internet, enabling scalability and flexibility without physical hardware. Virtualization is the core of cloud computing. It allows multiple operating systems to run on one physical machine, improving efficiency. In this presentation, we'll discuss different cloud deployment models and how Cognizant implements them using virtualization. Next is objectives to analyze public, private, and hybrid cloud models for real world needs and to evaluate them based on cost, scalability, performance, and security. Also, to understand virtualization and its practical implementation. Then, last but not least, to connect theory with Cognizant's real cloud usage. The next slide is about company overview. So, Cognizant Technology Solution is a leading global IT service and consulting company. It offers cloud AI analytics and digital solutions to clients worldwide. Because of its large client base, Cognizant needs a secure, flexible, and scalable cloud infrastructure to manage enterprise workloads efficiently. And the next slide is about the current cloud storage for Cognizant company. So Cognizant follows a hybrid cloud model that integrates Microsoft Azure, AWS, and Google Cloud Platform. This model supports scalability, multi-region deployment, and strong data security. Private clouds are used to internal applications and sensitive data, while public clouds support client projects and analytics workloads. Their Cloud 360 platform helps manage and monitor hybrid workloads effectively across multiple cloud providers. And further will be continued by Prarthana, my teammate, and thank you.
I'm going to explain the cloud deployment models. There are mainly three types of deployment models: public cloud, private cloud, and hybrid cloud. The public cloud is model where services are offered over the internet by third-party providers such as AWS, Amazon Web Services, Microsoft Azure, and Google Cloud Platform GCP. In this model, multiple organizations share the same cloud infrastructure. It is highly cost efficient because there are no need to maintain your own hardware. It also offers a very high scalability, meaning organization easily increase or decrease their resource usage based on the demand. However, the main drawback is that you have less control over the resource and security since the infrastructure is shared among many users. Example, startups often use public clouds like AWS because they are affordable and easy to scale. Next, private cloud. Private cloud is dedicated to a single organization. It is not shared with the others, which means it offers greater security, control, and customization. This model is usually managed either internally by the organization or by the third party vendor exclusively for the company. The advantages is high performance and very high security, but the drawback is high cost. It's expensive to set up and maintain your own cloud infrastructure. Example, banks or government institutions use private cloud to store sensitive data. Hybrid cloud. The hybrid cloud combines both the public and private cloud models. This allows organization to store sensitive data in private cloud with using the public cloud for regular workloads or large scale data processing. This model gives a balanced mix of cost efficiency, flexibility, and security. And setup and management can be complex because it requires a poor integration between the two environments. Example, like a company may keep customer information in the private cloud and while hosting it website on the public cloud. And the next slide, comparison table. The table gives a clear comparison between the three cloud based on the key factors such as cost efficiency, scalability, performance, and drawbacks. And the cost efficiency, public cloud is the cheapest because you pay only for what you use, and private cloud is costly as you own and maintain everything. Hybrid cloud is moderate in the cost. Scalability, public cloud scales quickly. You can add or remove resources instantly, and private cloud is limited by your hardware. Hybrid is flexible, scalable like public but secure like private. Performance, private and hybrid cloud generally perform better because they can be optimized for specific models. And public cloud performance are vary depending on network and shared usage. Security, private cloud provides the highest security. Hybrid cloud offers a high security, and public cloud is the moderate because it is shared. And the drawbacks, public cloud less control, and private cloud high cost, and hybrid cloud it's complex management. And the recommended model, next slide. um, Based on the comparison, the hybrid cloud is the most suitable model. It combines the advantages of both the public and private cloud, offering the best balance of for modern organization. The next will be further explained by my team member Priyanka.
I am Priyanka P. I am Priyanka P. Now I am explaining about the virtualization in Cognizant. This slide describes how Cognizant uses virtualization in its operation. VMware, ESXi and Hyper-V. Cognizant uses these technologies for server virtualization in their data centers. VMware, ESXi and Microsoft Hyper-V are hypervisors, software that allows multiple virtual machines to run on a single physical server. This helps reduce hardware cost and improve resources utilization. Optimization and isolation. Virtualization helps Cognizant optimize resources like CPU, memory, storage, and maintain separate environment for development, testing, and production. These ensure that one environment's issues don't affect the others. Next slide is virtualization overview. This slide gives a general background on virtualization. Definition of virtualization is the process of creating multiple virtual systems from one physical machine using a software layer called a hypervisor. Type of hyper Type of virtualization: full virtualization, para virtualization, OS level virtualization. Full virtualization: each virtual machine behaves like a complete physical computer with its own OS. Para virtualization: the guest OS is modified to work with the hypervisor, improving performance. OS level virtualization allows known as containerization. It allows multiple isolated user space on the same operating system. Benefits: efficient resource use, make better use of CPU, memory, and storage by running multiple systems on one server. Isolation and flexibility, each virtual machine or container runs independently, provide security and reliability. Foundation for cloud computing, virtualization is the core technique behind cloud infrastructure. Next will be continued by Chandana.
Hello everyone, I am Chandana. Today I am here to present about how to install the hypervisor and virtual machine in our host system. Uh, First, let's move to the first slide. In the first slide, they've given us some of the steps how to install, how to set up the virtual machine using a hypervisor to create a and a server environment. Here in the first image shows the installation interface of an Oracle VirtualBox. VirtualBox is a type 2 hypervisor, which means it runs on a top of an existing operating system like a single physical machine, which is very useful for testing, learning, or simulating the network environments. The installation itself is a straightforward. First, we need to install an VirtualBox from the official website and run the installer, then follow the steps. Once installed, the virtual manager interface allows us to create and manage the virtual machine. which I like to call our tools for simulating client and service machines. The next slide goes to that. That is a virtual machine we created is Ubuntu Client and Ubuntu Server. First configuration here is the Ubuntu Client virtual machine is designed to act as a client in our network. It has 2 GB of RAM and 1 CPU core, which is sufficient for a lightweight client operation. Its virtual hard disk is 25 GB and a graphical controller is set to VMS VGA with 16 MB of video memory. The boot order starts from floppy, then the optical, then hard disk, which ensures the system can check removal media first before booting the OS. For networking, it uses NAT, which allow the client virtual machine to access the internet via the host machine. Going to the next slide, the Ubuntu server, which is configured for a server task. It also has a 2 GB of RAM, but we allocated two CPU cores to handle the heavier processing. Its is having a 20 GB of a slightly smaller than the client. Since server operation here don't need a lot of storage, the boot order is to start from the hard disk first, followed by an optical and floppy, which is typical for a servers. Like the client, it uses NAT networking and the graphic setup is the same, but in a server graphic are not priority, so this is sufficient. Then during the setting, both the virtual machine requires an ISO image of for Ubuntu to install the operating system. The client VM is installed normally, while the server VM can also be automated using ISO for a unattended installation. Once the VMs are running, we can verify their network connecting by checking their IP address or a pinging external sites. Later, if we want the client and server to communicate directly, we could switch their network adapters to host only or a bridged model. In summary, using these images, we can see how we installed the hypervisor, created two virtual machines with separate roles, allocated the resources, and based on their task and configuration, boot orders and networking. This setup simulates a real client server architecture on a single physical machine, which is ideal for learning and testing purposes. Thank you. Further will be now continued by Kaustuba.
Hello everyone, I am Kaustuba and today I am going to present about the virtual diagram. Um, Here, this slide represents the concept of virtualization and how it is implemented in Cognizant cloud and infrastructure. At the base, we have the host machine, and which refers to the actual physical hardware system. Above it lies the hypervisor, a software layer that manages and allocates the physical resource such as CPU, memory, and storage. Um, and storage. The hypervisor divides these physical resources into several isolated environments known as virtual machine. Each virtual machine operates as an independent system with its own operating system and applications. Even though all of them share the same underlying physical hardware, this step allows multiple operating systems to run simultaneously on a single hardware system. Cognizant utilizes this virtualization technology within its data centers to maximize hardware efficiency, improve scalability, and deliver flexible cloud based service to clients. Next slide, we are moving to the conclusion. In conclusion, each cloud deployment models offers its own set of advantages. Among them, the hybrid cloud model best suits Cognizant global operation as it combines the flexibility and scalability of the public cloud with the security and control of the private cloud. Virtualization serves as the backbone of this model by enabling efficient resource utilization and scalability and ease of management. Together, the cloud computing and virtualization help Cognizant build a secure, efficient, and future ready IT environment capable of supporting its worldwide business operations. Moving on to the reference section. The reference used for preparing this presentation includes official documentation from leading cloud providers and virtualization platforms, AWS cloud documentation and Microsoft Azure documentation, Cognizant cloud servers, and VM ware and virtualization box documentation. This source provides valuable insight into the technical and operational aspects of cloud computing and virtualization. Thank you.
Hi, as I explained in the using the images in my presentation, I will let you show the implementation part. As you can see in my desktop, I had downloaded this Oracle VirtualBox. If I click on this, it will open this interface. While if As I explained in the image, I had already created the Ubuntu client and the Ubuntu server. In the Ubuntu client, you can see the details now. I had given the name that is Ubuntu client. Then we have an operating system of Ubuntu that is 64-bit. Then, as we explained, base memory is 2048 MB, that is nearly equals to 2 GB, and video memory is 16 GB. And you can see here, if we click on this, here a window will pop up. We can save the machine state and send the shutdown signal or power off the machine. As now I am power offing the machine, because I'm not doing anything. Then, as you can see here, the Ubuntu server is also similar to that. If I it has details are here. There is a network, audio, storage, display, and system. Everything is there. And if we need to create a new one, if we click on a new button, as you can see here, if we give the virtual machine name, it will create, and we can give a specify the what are all the storage, base memory, and number of CPUs. We can increase the CPUs, we can decrease the CPUs, and we can even increase the storage how much we want, and we can specify the hard disk. And these are all the features are there in this. And thank you.